Welcome everyone. In this video I'm going to be talking about the key features for polynomial graphs and things that you can tell about the equation based on the graph. So we're going to talk about a bunch of different things here. I'm just going to kind of go through them. The first one is the degree. So you can tell whether the degree is even or odd based on where the arrows are going, okay? So if your degree is even, that means your arrows are going in the same direction. So think about, x squared, right? It's a parabola. They're going up and down. Or sorry, they're either both going up or both going down. An odd degree is the opposite. Okay, an odd degree, the arrows are going in opposite directions. So you can think about like the cubic graph kind of goes like that, right? One arrow is going up, one arrow is going down. So you can tell whether the degree is even or odd based on the arrows, all right? So for this graph, both arrows are going up, so we would say that this is an even degree. Then we have local maximum or minimums, all right? So there's kind of a difference between like the absolute maximum, which is down here, and the local maximum, all right? And by the way, these should be written as points, okay? So the local maximum or minimum are basically anytime you get like something like this, like anytime you get a hill, it's going to be the bottom or top of that hill. So that point right there is a local maximum or minimum. This point right here is local maximum or minimum. Similarly, you have that point right there. And so you can kind of figure out what those are, and whether they're minimums or maximums by whether they're at the bottom of the hill or the top. So for local maximum, we only actually have one local maximum, and it's right there. So that point is 2, 0. And then we have two local minimums. We have, that honestly looks like it's like right in the middle. So it's like negative 1.5 and negative 4. And then we also have one at 4, negative 1, okay? So those are, different than the absolute maximum or minimum, which would be a maximum or minimum for the entire function. Now, actually none of these functions are going to have both, okay? Some functions might not have either, okay? Like for this function does not have a maximum. If it has arrows going up, that means there's no maximum, okay? Because it goes up forever. So it only has a minimum, it only has a lowest point, and that was this point right here, right? And we said that was negative 1.5 and negative 4. So that's the absolute lowest that the graph goes, okay? Then we have turning points, all right? So turning points are interesting because turning points are basically something that we've already talked about. Now, obviously, that should be written as a point. Turning points are literally what it means when the graph turns. So when the graph stops going down and starts going up. So this is a turning point, this is a turning point, and this is a turning point. Now, all right, think about that. That's basically the exact same as the local maximum or minimums, okay? Except you don't have to really figure those out. So what would we have our turning points? Negative 1.5, negative 4. We had 2, 0. And we had 4, negative 1. So turning points and local maximum or minimum are basically the same thing. The turning points are what create the local maximum or minimum. Now, there's actually a way to interpret the turning points, and we don't have much room here, but the turning points are the degree or I should say the degree of the polynomial is the number of turning points plus 1. Okay, and that's kind of important. You can figure out the degree just based on the number of turning points. So like for this graph, we have 1, 2, 3 turning points, so that means the degree has to be 4. And remember, this should line up with what you set up here. So we knew it had to be even. Now we can actually say, okay, it's actually 4 turning points. And the last thing that we're going to go over is increasing or decreasing interval. And this should be written as an interval, okay? So the increasing or decreasing interval, basically, the spots where they change, those are the turning points, right? And for the increasing or decreasing interval, by the way, it's x values only. Okay, and that's kind of important. So if we look at where our turning points are, we kind of want to look at where they are, on the x-axis, right? Because that's when, oh my gosh, that's when they stop increasing and they start decreasing, or vice versa. All right. So you want to look at where you start. All right. You're going to start with your arrow, and then, okay, we're going down, right? So up to the first turning point, we're going down. So remember, arrows always mean infinity. So on the left, that's going to be, you're always starting with basically negative infinity. So we're going from negative infinity to negative 1.5, okay? Then we start going up, and we go up until 2. So our increasing interval is negative 1.5 to 2. And then you switch. So you're basically switching back and forth, and wherever you leave off, you pick up on the next one. So from 2 to 4, we're decreasing again. And then from 4 to infinity, we are increasing. Okay, so it's only the x values. All right, you gotta keep that straight in your mind. All right, it's basically how that works. And so the last thing that we're gonna do, all right, the last thing that we're gonna talk about is the end behavior. Now we kind of talked about this in the beginning with the even or odd degree. This is basically, what happens on the far left and what happens on the far right, okay? Does it go up or does it go down? Basically, like where are the arrows going? So that's kind of what this is saying. The way that it's written like this. So as x goes to infinity, f of x goes to. So remember, this is input, this is output. This is your x-axis, this is your y-axis, right? So this number is either going to be infinity or negative infinity. Is it going up or is it going down, right? And so if x is going to infinity, that's going off to the right, positive infinity. If x is going to the negative infinity, that's going off to the left. So this would be the left arrow over here, all right? So for example, we look at this graph, all right? It's kind of blurry, but both arrows are going down. So therefore we know that both of these have to be negative infinity. So in both directions, on left and right, it's going down to negative infinity, right? And again, we can see our degree is 4, so it makes sense that both arrows are in the same direction. Here we have this kind of the same thing. We have another even degree, but this time both arrows are going up. So this time we know that both end behaviors are going to be positive infinity, right? Because they're both going up. The odd ones are a little bit tougher. All right, here you actually kind of have to pay attention. So where is it going up and where's it going down? So it's going up on the left, right, the left arrow. And remember, the left direction is the negative. So that's as x goes to negative infinity. So negative infinity, it goes to negative infinity. And oh wait, what am I even talking about? Negative infinity, it goes to infinity, okay? Because on the left it's going up, on the right it's going down. So as x goes to infinity, that's the right, f of x is going to negative infinity, it's going down, all right? And this graph is actually switched. So this time on the left it's going down, and on the right it's going up. So this is the right, remember, x to infinity. So on the right it's going up, and on the left it's going down. all right, over there. And so I kind of gave you one of each example, and you basically can figure out the end behavior based on the degree, which we already talked about, but also the leading coefficient, okay? So the leading coefficient, whether it's positive or negative, right? Because remember, negative flips it upside down. So if it's an even degree and the leading coefficient is positive, that's this example up here, all right? Both your arrows are going to be going up. If it's negative, it's flipped upside down, all right? Both your arrows are going down. For odd degree, positive leading coefficient, that's this example over here, all right? It's going down on the left, and it's going up on the right. And then negative is always flipped. So it's always flipped what the positive one was. So over here we look at negative, okay, it's actually going up on the left, and it's going down on the right, okay? And so based on this little table right here, you should be able to, fill out the end behavior based on just looking at the equation, okay? So if we look at this equation right here, we have a positive leading coefficient, and we have an odd degree. So positive odd, all right, that's this one right here. So that means on the right, it's going up. So this is the right. So as x goes to infinity, f of x is also going to infinity. And on the left, it's going down. So as x goes to negative infinity, f of x also goes to negative infinity. We look over here on this next one. This is an odd coefficient, or sorry, a negative coefficient with an odd degree. So we want to look at this one right here. And for this one, they're both going down, so the odd degree one, or sorry, the even degree ones are a little bit easier. We just know they're both going to be negative infinity, okay? So that's kind of how you do this. So I know I threw a lot at you. Hopefully, it wasn't too much and that everything made sense. If anything didn't make sense, just reach out to me, let me know, and I can try and explain it to you a little bit more. So yeah, if you have any questions, let me know. Other than that, have a great day.